Standard 9th, Science and Technology, Part 1st, Chapter number 2, Work and Energy. Up till now, we have studied about the work done, formula for work done, numerical examples, etc. And now we are going to study the energy. Now, what is energy? Here, the capacity of a body to perform work is called its energy. As energy is converted into work done, the units of these two magnitudes, that is energy and work, are also same. The unit of energy in SI system is joule and the unit of energy in CGS system is erg. The various forms of energy are mechanical energy, that is in Marathi we can call it as Yantrik Urja, heat energy, Ushnata Urja, light energy, Prakash Urja, sound energy, Dhvani Urja, electromagnetic energy, Vidyut Chumbakiya Urja, chemical energy, Rasayanik Urja, nuclear energy, Kendrakiya Urja, and solar energy, Saur Urja. Now, we will study in this standard 9th the two forms of this mechanical energy, and these two forms are kinetic energy and potential energy. First of all, we will study about the kinetic energy, and in this part we are going to study what is the kinetic energy, and also we are going to obtain the expression or the formula for this kinetic energy. Here you can see object B is placed at point C and it is stationary, that is initial velocity is u is 0, and a object which is in motion, object A, hits this object B. Then the object B is set into motion, that means it is displaced from point C to point D through a distance S. That means this object, that is object A, has an energy, and that energy is because of its motion, and then this energy is transformed to this object B and object B is set into motion. That means work is done on object B because of the energy in the object A, and that energy is called as the kinetic energy. We can define the energy like this: the energy which an object has because of its motion is called its kinetic energy. Obviously, when an object which is in motion hits any stationary object, it gets displaced. Okay, that means work done by a force to displace a stationary object B through a distance S, point to be noted, from point C to point D is the kinetic energy in object A. Now, further, we can see that kinetic energy in object A is equal to work done on the object B. Now, kinetic energy abbreviated as KE is equal to work done on object B. Work done is to be calculated by the formula F into S, force into displacement. Now, how to obtain the expression for kinetic energy? Suppose a stationary object of mass m moves or gets displaced because of the applied force F through a distance S. Then the conditions are like this: if its initial velocity is u, here the object was stationary, therefore u is equal to 0 meter per second. Due to the applied force F, an acceleration A is produced in that object. After time t, the velocity of the object becomes v. That means initially it was at velocity u, which is 0, and after hitting or after applying the force F, an acceleration is produced, and due to which the initial velocity changes to final velocity v. During this time interval, the object gets displaced through distance s. Then work done on that object will be W is equal to F into S. This will be equation number 1. But according to the Newton's second law of motion, what the Newton's second law of motion states, let us see here. Force is equal to mass into acceleration. According to this formula, we can state like this: F is equal to m into a. This will be equation number 2. Now, according to the Newton's second equation of motion, S is equal to ut plus 1/2 at square. As u is 0, 0 into t means 0, therefore S is equal to 1/2 at square. This will be equation number 3. Now, using this equation number 2 in the previous slide and this equation number 3 in equation number 1, we will get W is equal to MA, that is force, into 1/2 at square, that is S. Now, by rearranging this formula, we will get W is equal to 1/2 into m into a into at square. Now, next step will be W is equal to 1/2 m into a into a, that means a square. That means a square into t square. In all, we can put this like this: into bracket 80 raised to 2. This will be equation number 4. According to the Newton's first equation of motion, the formula will be V is equal to u plus at. But we know the object was stationary. That means initial velocity will be 0. If initial velocity is 0, then we will get V is equal to 80. Now, by squaring both the sides, we will get V square is equal to into bracket 80 raised to 2. This will be equation number 5. By putting this value in equation number 4, we will get the equation like this: W is equal to 1/2 m into 80 raised to 2 was there. Instead of that, we are putting this V raised to 2. Therefore, we will get W is equal to 1/2 mv square. This will be equation number 6. But we know that kinetic energy is equal to work done. Therefore, kinetic energy is equal to W equal to 1/2 mv square. Therefore, KE, that is kinetic energy, is equal to 1/2 mv square. Thank you.